Hello everyone, I'm Shreyas. I'm educated at an academy. You can follow me on the Learning app as well as you can see my new set of courses on the Learning app. So this is a lesson about the soldering process, which is a joining process in the mechanical engineering curriculum. I will be discussing about the various joining processes in the soldering process and the types of soldering processes. So please do rate it, review it and share it. And please do subscribe us on our YouTube channel, that is the Unacademy Engineering Curriculum channel. Thank you. So guys, let's start with our course elements of mechanical engineering. So I have given my introduction already. I am a B mechanical engineering student. You can follow me on the Unacademy user platform which is mentioned over here. So the target audience for this slide will be engineering students, general audience who are interested in mechanical entities, the people who are interested in machine related mechanisms, and automobile enthusiasts. The learning outcomes from this lesson will be, you guys will come to know the principle of soldering, what are the applications of soldering, what are the types of solders used, what are the types in soldering, and what are the advantages and disadvantages of soldering. So let's move on with our lesson, soldering. Let's start with the first set of slides. Let's have a quote before starting with our lesson. That is, art, it should be born from the materials. So because of the materials only, any art or creative science can be born or can be made out. So let's start with the principle. The principle of soldering. Before discussing about the principle of soldering, let's come to know what is soldering. Soldering, it is a group of joining process which is used for the joining of similar or dissimilar metals by means of a filler metal and whose melting temperature is below 450 degree centigrade. The filler metal used is usually called the solder, which is an alloy of tin and lead in various proportions. Soldering, it involves melting the metal filler or the filler metal and allowing it to flow into the gap between the two workpieces. The solder cools down and solidifies, forming a joint. The principle by which the filler metal is drawn throughout the joint is by capillary action. The resulting joint, though not as strong as the base material, that is the workpiece material, still has adequate strength, electric conductivity and water tightness that makes it suitable for many uses. So this is what the soldering is there. You can see the semiconductors and all, how they are soldered by the usage of a filler metal which is here. And this is the soldering, the hot base which is applied over there. So what is the surface preparation in soldering? So the surface preparation in soldering, it includes the thoroughly cleaning of the workpiece to remove contaminants like oil, rust, scale, paint and other impurities, either mechanically or by wire brushing. Then once the contaminants are removed, the next step is to apply a suitable flux. A flux is a substance which is either in liquid or semi-liquid state which performs the following actions. The flux primarily helps the base metals from oxidizing while they are being heated to the soldering temperature. The flux, it covers the surface to be soldered and shielding it from oxygen and thereby preventing oxidation during heating. The flux, it also acts as a wetting agent in the soldering process, reducing the surface tension of the molten solder and causing it to better wet out the parts to be joined. And flux, it also cleans the surface which by dissolving the metal oxides. Different types of flux can be used which include resin alcohol, zinc chloride, aniline phosphate and etc. The flux may be applied to the melted surface by brushing, dipping, spraying or by other methods. So this is how the whole thing applies or how the soldering application is used. You can see the circuit board on which the thing has to be joined and the semiconductors. So this is the tip of the soldering iron, this is the copper band and this is the filler material and how it is applied so that the whole thing, the lead can be joined to the component. So what are the applications of soldering? One of the most common applications of soldering is assembling electronic components to printed circuit boards, which we saw in the figure earlier. Another common application is making connections between copper pipes in plumbing system. Joints in sheet metal objects such as food cans, metal containers and rain gutters are made by soldering, as well as this process can also be used as a semi-permanent patch for a leak in container or a cooking vessel. So this is what I was telling. Assembling of electronic components to printed circuit boards, PCBs. So this is how it is done by the usage of soldering. So what are the types of solder? There are two types of solder, namely the soft solder and the hard solder. So basically the solder is an alloy which melts at low temperature. Let's go on with the soft solder. Soft solder, it is an alloy of tin and lead, which is the lead will be around 37% and tin will be around 63%. They have low melting points which range from 150 degrees centigrade to 190 degrees centigrade. A very small amount of antimony, usually less than 0.5%, is sometimes added to improve the mechanical properties of the solder, but this addition should be controlled, otherwise it might impair the soldering characteristics. Soft solders are used in those applications where the joint is not subjected to heavy loads and high temperatures. Let's move on to hard solder. Hard solder, it is a silver alloyed with lead, where lead is 97.5% and silver is 2.5%, or silver alloyed with copper and zinc, where silver is 50%, copper is 34% and zinc is 16%. The melting point of hard solder ranges from 300 to 600 degree, which makes it a high melting point, and it also depends on the type of alloy composition. Hard solder is used to make strong joints that can resist high temperatures. So this is actually a picture of the soft solder. These are actually pictures of hard solder. You can see how hard they are by looking at the image. These are actually another pictures of the soft solders, the various types of soft solders depending on the temperature. So let's go on to the types of soldering. Soldering methods are classified based on the mode of heat application. The heat applied should be such that it should melt the solder and permit the molten solder to flow quickly into the joint. The various soldering methods, they include soldering iron method, which I have already discussed. So I will be discussing the torch method, induction method, wave method, resistance method and ultrasonic method. So this is actually a torch method. So what is a torch method? Torch soldering, it utilizes the heat of a flame, you can see here, which is issued from a oxy-fuel gas torch. The torch mixes a fuel like gas, like acetylene and oxygen in suitable proportion, and it burns the mixture at its tip. The flame generated at the torch tip is directed at the workpiece with a flux applied on their surfaces. When the workpieces are heated to a suitable temperature, the solder is actually fed into the joint region to melt and to flow into the gap between the two workpieces. The solder, it also cools down and solidifies by forming a joint. You can see this is how the torch soldering works. You can see that the soldering of a cylinder is being done over here. So this is induction soldering. You can see induction soldering, it is by putting out coils in between the soldering surfaces. This is wave soldering. The wave soldering has become a very popular approach nowadays for soldering through whole components on printed circuit boards. This method, it uses a tank which is filled with molten solder. The solder is pumped and it flows. Its flow forms a wave of a predetermined height. The printed circuit boards pass over the wave, touching it with the lower sides. You can see this is the wave 1 and wave 2, and this is how the whole thing flows. This is actually resistance soldering, where the soldering is connected to resistances and it is fluctuated by the usage of a board or an electronic component. And this is ultrasonic soldering, where the soldering is used for making out letters or components or the manufacturing areas or the manufacturing detailing of components. So these are various types of soldering tips you can see. So what are the advantages of soldering? It has very low power requirements. It is a low temperature process, hence no thermal distortions and residual stresses are found in the joint parts. The dissimilar parts can be easily soldered, and thin parts, they can be joined easily by the method of soldering. What are the limitations of this soldering process? The flux residues should be removed after soldering, otherwise it can cause corrosion. Thick parts cannot be efficiently joined by the method of soldering. Since soldering temperatures are low, a solder joint cannot be used in high temperature applications and the strength of the joint is low, hence it cannot be used for load bearing members. So this is, you can see, this is a portable soldering machine which is used for resistance soldering. This is the components of the soldering. You can see this is the soldering here. This is a damp sponge over here. This is a solder over here. These are wire strippers over here, and this is a prototype board on which the soldering process will be taking place. So thank you guys. Any questions, please leave those in the comments box below. You can find me at the above URL here. This is my Unacademy user platform. And please do rate this course, review this course, and recommend the slides or the presentation done in this course. And please do follow me on the Unacademy user platform. Have a good day guys. Thank you.